Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Our today's topic is a very important topic from the examination point of view, which is series resonance circuit. इस इलेक्ट्रिक सर्किट से पहले हम 5 इलेक्ट्रिक सर्किट्स पढ़ चुके हैं, जिसमें अल्टरनेटिंग करंट का बिहेवियर थ्रू रेजिस्टर, कैपेसिटर, देन इंडक्टर डिस्कस किया गया. उसके बाद 2 ऐसे इलेक्ट्रिक सर्किट्स थे जिसमें इन 2 कंपोनेंट्स के कंबाइंड इफेक्ट को डिस्कस किया गया और उनके इंपीडेंस को फाइंड किया जाता है in the form of RC series circuit and RL series circuit. So now it's a turn of series resonance circuit. इस सर्किट में तीनों बेसिक कंपोनेंट्स ऑफ AC सर्किट यूज किए जाएंगे, यानी रेजिस्टर, कैपेसिटर और इंडक्टर. So before going to start this topic, series resonance circuit, I would like to discuss power in AC circuits or power dissipation in AC circuits. So in case of a pure resistive circuit, power dissipation is always maximum, and it can be determined by using these mathematical forms. P is equal to VI, I square R, and it is also equal to V square over R. So these mathematical forms can be used to determine the power dissipation in pure resistive circuit. But these mathematical forms are applicable only when V and I, voltage and current, they are in phase. If they are out of phase, then these equations are not applicable. So in case of pure resistive circuit, power dissipation is maximum, and it can be determined by using P is equal to VI. In case of pure capacitive circuit and pure inductive circuit, power dissipation is always 0. So pure capacitive यानी एक ऐसा इलेक्ट्रिक सर्किट जिसमें सिर्फ कैपेसिटर यूज हो रहा है, और एक ऐसा इलेक्ट्रिक सर्किट जिसमें इंडक्टर यूज हो रहा है, तो ऐसे इलेक्ट्रिक सर्किट में पावर डिसिपेशन हमेशा 0 के बराबर होगी, जिसको हमने वो क्वाड्रेंट्स को सपोज करते हुए प्रूव भी किया था. Now there is an other situation. If there is an angle theta between V and I, then power dissipation would be equal to the product of I and component of V, which is in the direction of current I. अब ये थर्ड सिचुएशन है. जो पहली सिचुएशन थी कि when there is a pure resistive circuit, in pure resistive circuit V and I are in phase. But in case of pure capacitive circuit as well as in case of pure inductive circuit, voltage and current, they have phase difference equal to 90 degree. That's why power dissipation is equal to 0. But there is third situation when there is angle theta between V and I, then power dissipation would be equal to the product of V, component of V and current I. So let we have these two quantities V and I, and they are making some angle theta. So in this case, we have to resolve voltage into its rectangular components. So these are rectangular components of V, which can be written as V cos theta and V sin theta. But according to the statement, the power dissipation is equal to product of current and the component of V, which is in the direction of I, and that component is V cos theta. So power dissipation in this case is equal to V cos theta into I, or we can write VI cos theta. Here cos theta is called power factor. Cos theta is called power factor. अब आप इस cos theta वाले power factor के लिहाज से ये जो पहली दोनों situations हैं उनको भी explain कर सकते हैं. When if there is pure resistive circuit, since V and I, they are in phase, angle between them is 0 degree, and we know that cos 0 is equal to 1, तो P VI के बराबर हासिल होगा, जैसा यहाँ हम already use कर चुके हैं. But in case of pure capacitive or pure inductive circuit, phase difference is equal to 90 degree. तो जब आप यहाँ 90 डिग्री यूज करेंगे and we know that cos 90 is 0, then power dissipation also becomes 0. So with the help of this mathematical form, we can determine the power dissipation in an AC circuit. Now it's turn of series resonance circuit, or it is also called RLC series circuit. Consider an electric circuit which consists of these three components: resistor, capacitor, and inductor, having resistance R, capacitance C, and inductance L respectively. They are connected in series with an AC source having variable frequency. यहाँ आपने याद रखना है कि जो सोर्स यूज किया जा रहा है उसकी फ्रीक्वेंसी एडजस्टेबल है, उसकी फ्रीक्वेंसी variable है. So let this is the electric circuit where these three components are present in series with an AC source. This is resistance R, then inductance, and the third component is capacitance. And we know that in series combination, the total voltage is divided across the components. So VR, VL, and VC are the potential drops across resistance, inductance, and capacitance respectively. The impedance of the electric circuit would be XL, XC, and R. ये प्रैक्टिस हम ऑलरेडी RC सीरीज और RL सीरीज सर्किट में कर चुके हैं. वहां हमने नोट किया था कि इंडक्टिव रिएक्टेंस लीड्स द रेजिस्टेंस बाय अ फेज डिफरेंस ऑफ 90 डिग्री and capacitive reactance lags behind the resistance by a phase difference of 90 degree. So with the help of this impedance diagram, we can calculate the impedance of electric circuit, which would be Z, and it is equal to R square plus XL minus XC whole square and whole square root. This is horizontal component and this is vertical component. XL is positive due to vertically upward and XC is a negative due to vertically downward. So XL minus XC is the net effect along y-axis. So X component square plus Y component square and whole square root. This is impedance of the electric circuit of this series resonance circuit. Here XL is equal to omega L, where omega can be replaced with 2 pi f. और यहाँ आप नोट कर सकते हैं कि this inductive reactance and the frequency of AC source, they are directly proportional to each other. And XC, which is equal to 1 over omega C, जहां आप ओमेगा को 2 pi f से रिप्लेस करेंगे, and frequency and capacitive reactance, they are inversely proportional to each other. So inductive reactance and frequency, they are directly proportional, but capacitive reactance and frequency, they are inversely proportional to each other. And it can be a relationship between inductive reactance, capacitive reactance with frequency can be described with the help of a graph. So in this graph, along y-axis, there is inductive reactance. And along x-axis, there is frequency of AC source. And this is the graph which is in the form of a straight line. And it shows that inductive reactance is directly proportional to the frequency of AC source. So with increase in the frequency, inductive reactance also increases. But with increase in the frequency, capacitive reactance will reduce. So in second graph, this is capacitive reactance, XC, and this one is the frequency of AC source along horizontal. So this graph shows that with increase in frequency, capacitive reactance decreases. Capacitive reactance कम हो रही है जैसे जैसे frequency बढ़ती है. So by using this concept, we have two possibilities. Possibility number one, when the frequency of AC source is low. So at low frequency, XC becomes greater than XL, because XC and frequency, they are inversely proportional. So XC becomes greater than XL, यानी capacitive reactance inductive reactance से greater होगी. So if XC is greater than XL, then circuit will dominate as a capacitive circuit. या इसका जो बिहेवियर होगा वो कैपेसिटिव सर्किट लाइक होगा. एंड नंबर 2, if the frequency of AC source is high, so at high frequency XL becomes greater than XC, and now circuit will dominate as an inductive circuit. So this is the dual behavior of this electric circuit at different frequencies. At low frequency, it behaves like a capacitive circuit, and at high frequency, it behaves like an inductive circuit. But there is an other frequency called resonance frequency. And this resonance frequency is a value of frequency between low and high at which XC becomes equal to XL. यानी इस फ्रीक्वेंसी पर ना ही XC XL से ग्रेटर होगा और ना ही XL XC से ग्रेटर होगा, बल्कि ये दोनों एक दूसरे के बराबर हो जाएंगे. एंड दिस फ्रीक्वेंसी इज कॉल्ड resonant frequency. So straight line is for the inductive reactance, and this curved line is for capacitive reactance. And this is the point where inductive reactance and capacitive reactance, they have same value. So this particular frequency is called, it's a resonant frequency, where XC and XL, they have same value. जबकि इस point की left या right side पर sometimes XC becomes greater than XL and sometimes XL becomes greater than XC, but at this particular point XL and XC, they have same value, or in other words we can say that their difference is equal to 0. XL minus XC is equal to 0 and XL becomes equal to XC. We know that XL is omega L. ओमेगा के साथ जो R हम यूज कर रहे हैं, that is for resonance. So omega L and is equal to 1 over omega C, where omega is 2 pi F. So 2 pi F into L is equal to 1 over 2 pi F into C. So here FR square, which is resonant frequency, becomes equal to 1 over 4 pi square LC. By taking square root on both sides, FR becomes equal to 1 over 2 pi LC square root. So with the help of this mathematical form, we can determine the value of resonant frequency for this series resonance circuit. 1 over 2 pi LC square root, where L is the inductance and C is capacitance of the circuit. Now there are some characteristics of this resonant frequency. So characteristic number 1, the resonant frequency is 1 over 2 pi LC square root, and it depends upon inductance and the value of capacitance. So this is first property, that is about the resonant frequency. Second property, at resonant frequency, impedance of the circuit becomes minimum, and that is equal to R. कि जब resonant frequency occur होगी तो at this particular frequency impedance of the circuit becomes minimum and it is equal to R, which can be proved graphically as well as mathematically. So in this graph, XL and XC, they are opposite in direction. So when they become equal to each other, they cancel out. जब ये XL XC को cancel करेगा, only resistive or resistance is remaining. So that's why impedance of the circuit at this resonant frequency becomes equal to R. And mathematically, with the help of this equation, we can prove this one. If XL and XC, they cancel out each other, then Z, which is impedance, becomes equal to R, which is the resistance of the circuit. So at this particular frequency, which is called the resonant frequency, circuit is resistive. यहाँ सर्किट रेजिस्टिव होगा, जबकि इससे पहले हम प्रूव कर चुके हैं कि लो फ्रीक्वेंसी पर सर्किट कैपेसिटिव लाइक बिहेव करेगा और हाई फ्रीक्वेंसी पर इसका जो बिहेवियर होगा वो इंडक्टिव सर्किट लाइक होगा. बट एट दिस पर्टिकुलर फ्रीक्वेंसी सर्किट विल बिहेव लाइक अ रेजिस्टिव सर्किट. और आप जानते हैं कि रेजिस्टिव सर्किट में वोल्टेज एंड करंट, दे आर इन फेज. So due to in phase, power factor becomes equal to 1. So with the help of these waveforms, we can describe this characteristic number 3. Here the first waveform, that is for a capacitive circuit where current leads the voltage by a phase difference of 90 degree. In second, which is the resistive circuit at resonant frequency, when V and I, they are in phase, there is no phase difference, 0 degree phase difference. And the third one is the inductive circuit where current lags behind the voltage. In this case, current lags behind the voltage. So they have different phase, but at resonant frequency, circuit is resistive, and V and I, voltage and current, they are in phase. So at this particular frequency, there is 0 degree phase difference at resonant frequency only. So instead of this resonant frequency, there would be some phase difference between them. And power factor is 1 when circuit is resistive, and it can be proved mathematically. We know that power factor is cos theta, and theta is equal to 0 degree, और cos 0 की वैल्यू 1 होगी, लिहाजा पावर फैक्टर जो होगा वो 1 के इक्वल होगा. In characteristic number 4, at resonant frequency, the value of current becomes maximum because the impedance of circuit is minimum. क्योंकि impedance कम है तो current maximum होगा, और इसको भी आप इस ग्राफ की हेल्प से डिस्प्ले कर सकते हैं. So this is resonant frequency. So at this resonant frequency, value of current is maximum, and it can be written as I naught is equal to V naught over R, where I naught and V naught, they are peak values of current and voltage respectively. Fifth point, at resonant frequency, the voltage drop across capacitor VC and voltage drop across inductor, that is VL, and they may be much larger than source voltage. कि रेसोनेंट फ्रीक्वेंसी पर जो वोल्टेज ड्रॉप की वैल्यूज होंगी, चाहे वो VC हो चाहे वो VL हो, वो सोर्स वोल्टेज से ग्रेटर हो सकता है, VC की वैल्यू भी और VL की, बिकॉज दे कैंसल आउट ईच अदर. आप जानते हैं कि इन केस ऑफ कैपेसिटिव सर्किट VC lags behind the current, but in case of inductive circuit, it leads the current. So when they are in opposite direction, so they cancel out each other. So if they cancel out each other, then their value may be much larger than source voltage. So these are the characteristics of series resonant circuit. Thank you.